I would like to share that's possible. Okay, can you all see my screen?
Yes, we can. Yes, we can.
Do I need to show my face as well?
It will be nice to see the new face and not the profile picture.
Okay, let's see if that's possible. So. Can you see my face? I don't know if that's possible. Okay, I think I can see it right there. All right, so welcome to the UIGIS workshop series. We're starting off with the introduction to Geographic Information System, GIS. So a little bit of intro about myself. So I'm a geospatial software engineer. I have a background in GIS, then I'm a self-taught software engineer. So merging it together forms the geospatial software engineer. And I'm a young innovator, founder of Spatial Node. And currently I consult for Integration, a German-based organization. And I have a podcast. I'm a Youth Mapper Research Fellow, 2020 Esri Young Scholar Award for Nigeria. And I love open source so much and capacity building, especially community development. And then when I'm not on my system, I'm usually at the estate sports center playing table tennis or dancing. So today we are going to be having a very gentle introduction to GIS. We're going to be looking at the components of GIS and then spatial data science and the employability potential in GIS, and then what next after GIS. So let's can that person
Someone, can you please mute yourself? Thank you.
Okay. So so much. So GIS, before I talk about GIS, I would like to talk about geospatial data, because at the end of the day, GIS is data driven. Without data, you can't do anything with GIS. And I'm assuming most of us have a background in data analysis. So just want to more like compare what a normal data looks like and what a GIS data looks like. So usually a normal data, say bank transaction data, usually have the amount, the transaction that you're performing, either it's a deposit, a cash withdrawal, or a POS transaction, and then the timestamp. So this is a normal data, which still makes sense. You can derive insights from this, right? But there's little insight you can derive from normal data compared to when you pin the data to a particular location on the Earth surface. Latitude, or elevation, or an elevation. Latitude. Ideally, with normal data, when the bank person mutes his stop it. Sorry about that. So when you have sign up.
Sorry, I think maybe we can mute everyone. Maybe the host can do that.
Exactly. The background noise is too much. Horizontal direction. Yes.
Ibrahim Oladejo, kindly unmute your mic.
Okay, thank you. So as I was saying, sorry about that actually. So ideally, when we have this kind of data, these are the kind of data we are familiar with, which is still very useful. We can derive insights from this. At least from this, you can know the date or the month you spent the highest amount of money, right? You can know the highest amount of transaction you performed, if it's cash withdrawal, POS withdrawal, or
4 hours. 4 hours is a lot for me. Yeah. So far that thing is not
Oh,
compulsory.
Mr. Emmanuel, please kindly hold on. Let me reach out to
But they
Mr.
will give me
Ahmed.
that skill like
Can make me co-host so I can handle this.
okay, that's
Unibadan. Yeah. Unibadan, first and best. Our Unibadan real. I'm product of Unibadan.
Okay, Mr. Emmanuel, you can go on.
all right. So as I was saying, this is how a normal data is structured without a location component. So this is like an hypothetical data of bank transactions. So from this, you can derive insights. Quite all right. You can know the highest or the months where you spent the highest amount of money. You can know the type of transaction you performed. Maybe you do a lot of POS withdrawal. When you see your bank statement, you can get to know, okay, in January, I did a lot of POS withdrawal, right? In January, I spent X amount of money. So that's just a picture that as how normal data are. And this can be anything. This can be data about your businesses, your customers, etc. So, but when you start to add the X and Y to that data, it becomes a geospatial data in the sense that it has a location component now. So now you don't just know that, okay, you spent X amount of money in a particular amount. You also get to know where you spent that money, right? You also get to know where you did deposits. So say for example, you deposited money and you didn't receive the credit alert in your bank account, or the person that you're paying the money to does not receive the deposit. Of course, the first thing you will ask yourself is, which bank did you use and where was the bank you used, right? Before you now go ahead to that bank and lead your company. So that shows that knowing the where of something is very important. Now, let's even look at what's happening in Nigeria. Currently in Nigeria, there's flooding happening everywhere. And Lokoja, I think, is the one that is experiencing the highest. Lokoja, Anambra, and many other states down south. So all these things are happening somewhere, right? So if you want to solve that kind of issues, we are not going to be asking like the first thing we're going to be asking is where is this flooding happening, right? Flooding is happening in Nigeria. It's not like the whole of Nigeria is flooded. But when you ask yourself, where is the flooding happening? Oh, it's happening in Lokoja. Then you start to think of how you can avert it and possible control measures to carry out. So knowing the where of something is very important. And this is just an example of how it looks like when you have, or when you transform a normal data into a geospatial data set. Because with this, you can get to have an overview of the banks you have visited, for example, the locations where you make your POS withdrawals, the locations where you make your cash withdrawals, etc. So where is like a means of enriching a normal tabular data set. And when you add where to a data set, you get more insights. You are in Ibadan and you want to sites you want to maybe open a new branch for your customer, your business, it makes sense for you to, what you ask yourself is, where do you want to open the branch? That's the first thing you want. So you have your current branch, and you want to extend your business. What you ask yourself is, where do you want to open the second branch? And when you're asking yourself that, you start looking at different data sets. Okay, I want to open it in Agodi. What's happening in Agodi? What kind of people are there? Is the place accessible? Or you start looking at different data sets, combining it together before you decide where to open your new branch. So the power of where is in the world, GIS is trying to study the science of where, trying to use the knowledge of where to answer questions and to make decisions. So there's a lot of power when you know where something is. The crime is happening in Nigeria. When you ask yourself, is where, right? It's where you know the way of something before you start to think of how you can solve it, what to do to solve it, when to solve it even, and why not you should not solve it or something. So where is like usually the starting point, and so this slide is just to show us how it looks like when you have a normal data sets and what can happen when you transform it to a geospatial data set. And when you have an address like this and you're trying to convert it to X and Y, because usually in Nigeria we have just addresses, that's usually the starting point. You collect address about different things. But those addresses doesn't really make sense to computers. They don't understand that somewhere is posted in Nigeria. What they understand is longitude and latitude, that's X and Y. So there's a concept that we use to transform these addresses to X and Y, which is called geocoding. And then there's also a way we can transform X and Y back to addresses as well, which is known as reverse geocoding. So you might what's important, you knowing that there's power when you have location components, when you add location components to just normal data, you can derive a lot of insights that way. So in the GIS industry or in the GIS world, we have different ways we represent data, which we call the data structures. So I will assume that most of us have worked on only tabular data stored in CSV or Excels, or maybe via advanced data from databases. So that's general. But in the GIS world, we have two major ways we store data sets, which are vector and data and raster. So all these data sets still have location components. It's just that the structure at which they are stored is different. So vector is more like a way we represent the real world. For example, on Google Maps, we use line to represent roads. We use like polygons to represent buildings. We use lines to represent rivers. And then we use point to represent points of interest like ShopRite and banks and stuff like that. So those are vector data sets. We use it to represent real world. We use geometry to represent real world, because at the end of the day, GIS is trying to understand our world, attaching the location components to these data sets, and everything around us is somewhere. You are currently joining me from somewhere, right? So if I want to represent where you are joining me from, say for example, at the end of the call, we want to kind of represent the location of participants, right? The way we represent that is by using vector data structure, because we can convert all these addresses into points and put it on the map, and we can be able to see that, okay, during this call, we had people from this part of the Nigeria, this part of the world, this part of Ibadan. So vector data set models the real world, everything around us, rivers, roads, infrastructures, buildings, using geometry. And the starting point is usually the longitude and latitude, the X and Y, because when you model a point of interest, for example, you use X and Y or long and lat. And when you want to model a road, you still use X and Y, just that the road now is now a line, and a line is like the combination of two or more points, right? If you want to represent a line, for example, you don't just draw a line. Even if you draw a line, at the end of the day, the line still comprise of several points, but this time they are now connecting. We call it nodes or vertices in GIS. Or what you just know is that, okay, vector data sets are used to model the reward, because this is the only way we can be able to analyze this information in the GIS environment. The GIS does not know that this is a road. It can only know this is a road when you tell it it is a road. And how will you tell it it is a road? By using points or lines or polygons to represent these features. And vector data sets are stored in different formats. And the most popular one is the Esri shapefile, which is the format that is created by Esri. So Esri is one of the leading GIS companies in the world, and they have this software, GIS software, which is very, very popular. And they also have this format as well, shapefile. So it's also very popular. So just like if you ask someone that is new to GIS or even an experienced GIS personnel, the Esri shapefile is usually the format that they talk about a lot. It's very popular. But there are also other formats actually that are even more better than the Esri shapefile, depending on your use case anyways. You have the GeoJSON. If you're into web development, you might know you might already know what JSON is. JSON is JavaScript object notation. So, but we have the geospatial flavor of that, and that's the GeoJSON. Then we have KML and KMZ. So KML is Keyword Markup Language that was developed by Google, and KMZ is like the zipped version of that KML. We have GeoPackage, we have flat GeoBov and GeoPackage. So all these data sets, all these formats are just different ways we store data, just like we store rows and columns in CSV, command separated value. We also store rows and columns in Excel. We also rows and columns in even in databases like SQLite. You can also store rows and columns in data frames for those that use pandas. So all these things are just like the way we store these data sets. At the end of the day, these data sets are still points, lines, and polygon, right? Or multi-polygon. They can be also complex as well. But the way we store these data sets such that we can easily share it between each other is by using these formats. So we have the Esri shapefile, we have the GeoJSON, and then we have a lot of them like that. So if you look at this image, you can see this river is this one is representing the river, and this is a points of interest, and then we have polygons. So you can think of your state boundary of local government boundaries as polygon. You can think of the Nigerian administrative boundary as polygon. So even buildings, you can represent buildings as polygon. You can also represent buildings as points, depending on the scale you're looking at. Because, for example, on Google Maps represents almost everything as points because it's easy to work with points. But at the end of the day, these structures are actually polygons. When you say you're going from point A to point B, on Google Maps, you won't see a building, you just see a point of interest. But that structure is actually a building. So you can use them interchangeably depending on what you're trying to build or the project you're trying to work on. So, but at the end of the day, all these features, all these geometries, we use them to represent the real world so that we can be able to work with them and analyze them in a GIS environment. So these formats have their own pros and cons. For example, Esri shapefile usually comprise of at least 3 files, right? While GeoJSON is just a single file. So if I want to share with you an Esri shapefile of, say, UI boundary, for example, I will need to zip it before I can share it with you. Otherwise, I will need to send you 3 different files: the projection file, the database file, and the geometry file. So I don't really want to go into details of this, but just know that there are different GIS formats to store GIS data. So then we have the raster data set. So this one is like pictures. I like to explain this as pictures because at the end of the day, they are just pictures. There was even a meme I saw on Twitter that the satellites in space are capturing the heads, or they are like the selfies of the Earth's surface, because at the end of the day, they are up there in space and they are revolving around the Earth and taking pictures every minute or every seconds. So they're like the selfie of the world. So these guys right here provide us the way the world is actually, like the way it is actually, and even beyond that, even more advanced, because they can provide us different informations. And the way they do that is by storing it in raster formats. So raster is the same thing as the normal pictures that we have around us, you know, the one you snap with your phone. Difference is just that your camera is transforming that into what you can easily understand. That's, you know, you can see the color, the way it is in reality. Why these guys right here are stored in different bands. And so this raster more like stores data in grids. An example of this raster can be JPEG, it can be PNG, they can be like normal pictures are raster, because if you have a picture, I don't know if it's possible on the phone, but if you can zoom in very well into those pictures, you'll see that you'll be seeing pixels, grids. So these grids are raster data sets. They store data in grids, like very small squares. So within those squares are different values. So the values are determined by the sensor, in this case your camera. That's why there's always difference in resolution between different pictures that is taken by different cameras. If I snap a picture with my Samsung, it might be more clearer than you know, a picture is taken with Techno, and it's because of the sensor of that of the two cameras. And at the end of the day, the data are stored in pixels, just that the values between those grids varies. For example, my own might have a value range of between 0 and thousands of values just for pictures, while a Techno might have a very limited value range. So these data formats. If you are talking about these data formats, you have to start going into remote sensing, which is beyond the scope of this session. So I don't want to go into that. But just know that you can also store raster data, GIS data in raster formats. An example of these are usually drone images. When you take a picture with drone, they usually stored in raster data sets and not vector. So usually raster is usually the starting point. Yeah. So you derive vector from raster in a way to think about it, because if you want to represent the real world in points, lines, and polygon, you need to be able to see the real world first, right? So, and the way you see the real world is with raster, like Google base map, for example. On your Google Maps on your phone, you can switch to satellite view, so you get to see how the real world is, right? So it's when you now see the real world the way it is, before you can now start converting it or digitizing it to vector formats. So these guys right here are used a lot when it comes to analyzing different features on the Earth's surface. Say, for example, you have a farm and you want to analyze your farm. You want to study the health of your crops. You can use these guys right here. You can't use vector data to study the health of crops because they are purely geometries. You can't derive insight from them. You can, of course, use vector data sets to do something like shortest route algorithm, just like Google Maps, where you see different routes, follow route A, this one is shorter, 5 minutes faster, and these kind of things. You can use vector to do that, but you can't use vector to understand the health of your crop. You can't use vector to model flooding in Ibadan. You can't use vector to do, like, you can use vector to do some really complex analysis. You can use vector to do land use land cover, to do bonds index or turbidity index, or to study drought change in the north. So when it comes to like really studying the real world, analyzing stuff, you can't use vector to do it. So they have their own pros and cons. So by the end of the day, the starting point is usually the raster data sets, because so like what the satellite captures, and it's from there you can now start deriving vector from it before you use vector to do any other thing you want to do. Of course, vector has its own pros as well. Vector are used in, like, vectors are easily shareable. That's why they use it in all these web maps and all these mobile applications like Google Maps. Even boats use vector as well. So, and then we have tabular as well. Tabular is one you're probably familiar with, Excel, CSV. So we can also store geospatial data in this format, but we can't work with them directly in a GIS environment. There's a trick we use to import them in the GIS environment before we can be able to work with them. So there is a favorite quote by Jimmy Buffett. It says, "Without geography, you are nowhere." So understanding the way we are is very, very important, because as we all know, location matters. Location matters a lot in our life. So using these tools, these formats, and technology to store, analyze, and manipulate geospatial data is what we know as GIS. So GIS, you can see, it's not like it's not a standalone thing. It's like it combines the use of technology, which can be in form of GIS softwares, to store data. When you're storing something, you start thinking of database or different data formats, like the one I mentioned earlier, like GeoJSON, shapefile. Then you have to start thinking of analyzing these data sets, manipulating it, and visualizing it. So that's what makes up GIS. So, and it's an acronym for Geographic Information System. So this is like a tweet I saw on Twitter that not all GIS is labeled as GIS, but geospatial data is everywhere. And that's very true. Geospatial data is everywhere. Many of us might even have it in our organization, but we are not aware of it. And in fact, some of us might already be doing GIS, but we are not exactly aware that we are doing GIS. So, but this data is everywhere. When you have data that has X and Y, long and large, you already have a geospatial data, and you can do a lot with that data set. You can do a lot with it. So GIS, like I said, is not standalone. GIS has components, and it has 5 of them. So the first one is the Gis Experts, which is everyone on this call right now. So we are the people, we are the one that do the GIS, right? So the GIS experts can include those that are purely into GIS, like myself. I studied GIS in school, so, and it can also include those that learn GIS via maybe workshop or training such as this, or those that apply GIS in their work. So far you know how to use GIS, you are part of this category of people, the GIS experts. Then we have data. Data is very important because GIS is data driven. At the end of the day, you can't do anything without data. If you don't have data, you can't do GIS. So, and there are different data. One of the ways is remote sensing, which is the act of getting information about and that's what satellite do for us. They help us to get information about places without us going there. For example, from Google Maps now, or Google Satellite View, you can get to see even places you've not been before, right? So it's not like Google went there to capture all the images of those places. They use satellite to do that, because there are some places that are not accessible, like the cold regions that are not accessible by normal humans. So you can't even go there and fly your drones. You have to use remote sensing to do that. So remote sensing is one of the data sources, like is the biggest data source for GIS projects, because we have a lot of satellites out there that is capturing data for us every day. Because this world, we are strangers in this world. So if we want to understand this world, we need to get a lot of data about it. And the way we can get data about it is through remote sensing, because that way we can get data about the oceans. People use remote sensing data to measure ocean depth, climate change, Amazon rainforest, different types of analysis and research works. And the source of this data is usually remote sensing. And of course, there's field survey as well. People go to fields to kind of verify remote sensing data sets, or to even collect a different data entirely. So depending on project. And then we have business data. These are the data we collect via businesses. Just like in banks, they collect different data with addresses. When you go to bank to open an account, they ask for your address. And at the end of the day, what they do is address verification system to verify that you actually live in those addresses. And how they do it is by using GIS to geocode your addresses and overlay it on Google Maps, for example. Not just like a basic way of how they do it, but of course there's some technical things that go into it. But the idea is just to kind of match your address, the address you provide to them, to confirm that, okay, this person's actually living here, and confirm that this address actually exists. That's the most important thing, that, okay, this address actually exists. And they can't be doing it one by one. They can't be going to the field one by one to check for all the addresses of their customers. So the fastest way they use, the fastest way or the fastest approach to that is to use a GIS, and that's what they do. Some banks do that. So they employ GIS personnel to help them do and verify the addresses they get from their customers. And let's say there are different businesses that also get addresses from customers. So once you start collecting addresses from customers, you already have GIS data that you need to start making use of. So, and then there are different software to analyze these data sets. We have ArcMap. So ArcMap is a software by Esri. We have ArcGIS Pro. So ArcGIS Pro is another software by Esri. It's like it's the one that is trending now, because in a few years, I think ArcMap will be out of the market, and ArcPro would be like the only software that Esri will be supporting. And then we have QGIS, which is like the open source version of ArcMap. We have Python. So if you already know Python, you can already do GIS actually. We have R, we have Google Earth Engine or GE. So there are a lot of GIS software actually, a lot of them, a lot of GIS and remote sensing software. These are just a few. These are just a few of the available software. And having this software and data is not enough. You need to know what you want to do. And this is where that's why we have methods. So methods is, okay, you have a data set. What do you want to do with it? You even have software. What do you want to do with it? So you need to know the kind of analysis to perform, the kind of algorithms to run. And this is what the methods is all about. The analysis you perform on GIS data sets, the algorithms you run on GIS data sets, the queries you perform, the manipulations you do, is where the methods, that's what the methods component is all about, the analysis majorly. So that's why not everyone can do GIS, because there are a lot of analysis, and if you make a mistake with analysis, it can lead to poor decision making, and it can lead to lots of money for businesses. So this is very, very important. And then the hardware. So this usually goes with the data collection and the software. Like our laptops are hardware, for example. The laptops that we install the software are hardwares. The drones that we use to collect the data sets, the satellite sensors, the servers that is going to be hosting our maps. For example, Google Maps base map is hosted on a server. That's the GIS hardware. The iPad that we take to the field to collect data is hardware. So all these are components of GIS. They usually work together. They are not standalone. You can't have a software without hardware, for example. You can't install your software on just anywhere. It has to be on a computer or a server, and that's hardware. And when you install your software, you can't just do GIS without data. You need to get data. And when you have data, you can't just be looking at the data. You need to analyze it. And that's when you look at the methods. And all this thing is being done by someone, which is you, and not the machine. So And that's where we have the GIS experts. So all these components, they work together. And these are the 5 components of GIS. Okay, so GIS is very broad, like the quotes or the tweets I shared earlier that some people already use GIS, but they don't know that they use GIS. So I was just checking the the Nigerian context, and I figured that even Jumia uses GIS. So this is a package tracker by Jumia, where you get to track your package. So here they use vector data sets, as you can see, a line to show you the routes of the package, and then points to show you the checkpoints or the stops of the package. And then the platform, this web interface, as you can see, there are maps there, and maps to show one of the outputs of GIS. So, which is very interesting. So this is like a very basic example of using GIS, to track your package. And it's very exciting to see that even Jumia is using the web GIS. So GIS has different applications, so you can categorize it as a web GIS. So it's very interesting to see. So with this, you can put your tracking number right here, and then when you press enter, then you see the package stops, and you can track the package where it's currently at, and the even possible the next location. So it's very interesting to see Jumia using this website package tracker, so track packages, leveraging GIS. So I believe they're like a very heavy user of GIS in this country, because they deal a lot with addresses. They don't deliver, but you have to provide your addresses, and at the end of the day, they convert these addresses to coordinates, and then they overlay it on the map, because that's what the computer understands: coordinates, X and Y, long and latitude. Then they put it on the map, so you can visualize it. So yeah, this is just one. Then we have another one, Snapchat. Snapchat, I don't know if you I think everyone should know what Snapchat is. So Snapchat also has a map view. So on the map view, you can more like see what you can see on the mobile app. Normally, you can also see it on the map, because everybody that is using Snapchat are posted from a particular location on the Earth surface. So Snapchat convert those locations to X and Y, and then they put it on the map, and then you can see what people are posting in real time. So all these hotspot zones are like places with high posts. So if you zoom in, you'll see different posts by different people, and you can see what's happening all over the world in real time. So it's also very interesting to see even social media platforms using GIS to visualize the users and engagement on their platform. So they use this to understand where their customers are coming from and where they should focus their adverts. From this now, for example, they can see that, okay, we have a lot of users from Saudi Arabia, we have a lot of users from India, and we have a few, or even none in South America. So if they want to do any PR, they know they will need to target South America for their PR, and even some part of Africa for their PR. Of course, this is not updated, so maybe things have changed now, but you can always check it via this URL to see what's happening everywhere. So this is very important for if you want to make business decisions. You get to know where your customers are or where your users are, and then you get to know where your potential users can come from, and that's where you're going to target your adverts, or even open your new branch. Then this one you're probably familiar with. So this is the popular Google Maps. They are the heavy user of GIS. So these are just lines to show traffic. And then you can also see street view. So this is just 3D panoramic images. So Google, they are trying a lot. They use GIS a lot, which is very interesting, because at the end of the day, a lot of people are using GIS, but they don't know they use GIS. So, which is actually very good. You don't need to know you're using GIS. So far, you're getting your problem solved. So everybody use Google Maps to find addresses, to locate stores around them, for example. And what's happening under the hood is GIS. So these are raster information, as you can see. These are captured by satellite. Or after they're captured by satellite, then we start to extract vector information from them. We start to draw points, lines, and polygons. So you can see all these points of interest. Those are vector informations. So, say for example, now you are right here, you want to check the stores around you, just like we do in Google. Hotels near me, restaurant near me. Under the hood, what Google does is to get your current location and then draw an imaginary boundary around you, say of 50 kilometers or 100 kilometers, and then search within the database for points of interest that falls between or within that imaginary boundary. And then Google will render it to you on the Google Maps to show you, okay, these are the results. So what's happening at the hood is an algorithm called geofencing. So that's what's happening. Geofencing is running under the hood, or you are seeing the results, or you won't know. But you're getting the result, and that's what that matters. And that geofencing is a GIS algorithm, right? The same thing with finding routes between X and Y in Google Maps. Was also running
Excuse me, sir. Please speak up.
Algorithms. Okay, sir. Is it much better now? Sorry about that. So I don't know what's wrong with my mic. But can you hear me clearly now?
Yes, it is better. You can go on.
Okay, cool. Okay, so under the hood, what's happening are different algorithms, different GIS analysis that Google has already written there under the hood. So the point is that this is also another application of GIS that we use every day in our day-to-day lives. We use Google to check the routes from point A to point B, the shortest routes. We use Google to find something around us, and all these are powered by GIS, embedded in software, which is also a component of GIS as well. So I just felt I should show that to us. And then there are lots more, Uber, for example, use GIS heavily. Boats use GIS heavily. In fact, these boats guys, there was a time I was informed that they specifically hired a team of GIS personnel in Nigeria to help them improve their platform, because they were using Google Maps before for their geocoding system. So that geocoding system is more like, when you search for address on boats and you start seeing results. So what's happening under the hood is geocoding. As you start to type your address, where you're going from and where you're going to, you start to see the results. So they were using Google Maps for that, Google API, and Google is so expensive because they have millions of active users per day. So a lot of people use their app, and in turn leads to a lot of dollars to pay to Google, because Google charges per request for their geocoding API. So they had to start looking for other alternatives. So they had to hire a team of GIS engineers to help them build their own in-house geocoding system. So if you notice now, if you go to Bolt and you want to search for address, you won't see that Google logo again. You'll see something like OpenStreetMap, GeoNames, and other platforms. So these guys use GIS a lot to improve their even routing and also their geocoding. And there are a lot of people that use GIS, like a lot of people that use GIS. Amazon uses GIS, Amazon Meta, Facebook, Snapchat, Mapbox. A lot of them uses GIS. So yeah, It's a very interesting technology. So not to confuse us, we have GIS, we have Geospatial. In fact, you might be hearing Geo Data Science, you might be hearing Geoinformation, you might be hearing Geointelligence, a lot of geo stuff. So what's common is that these guys still deal with geography. Geography is still the foundation and the bedrock of all these terms. And what's also common to them is that they all deal with location data. That is a data that has a where component, that is a location in space and time. So, and at the end of the day, what we are using this data to do is to study our world and solve problems and derive decision-making insights. So when you see geointelligence, when you see like there are a lot of terms that has geo as a prefix. So at the end of the day, they have this three in common: geography, location, and at the end of the day, we're using it to study our world and solve problems. So yeah, let's talk a bit about geospatial data science. So if you have a data science background, you don't need to switch into geospatial, like you don't need to switch your career into geospatial like that. So you're already doing a bit of geospatial, just that the data you're working with is a data that does not have a geospatial component. So what you just need to do is just to add geospatial component to it, and then you will be very powerful. So geospatial data science is still a subset of data science, but it focuses on actually using geospatial data to know where and why things happen. So I got this from Cato. So Cato is like the leading company that advocates for geospatial data science. They do a lot of geospatial data science in business, in improving business operations. So you don't just know how things happen, because with data science you can answer questions of what happened to Mr. X. Yeah, even be able to answer questions of why is our company revenue increasing or decreasing in X months. You can answer those kind of questions with normal data science. But when you now add geospatial to it, you'll be able to answer where is this happening? And that's very important. Where are customers coming from? Where do we have large amounts of users? Where should we install or site our new branch? Where should we target our ads? When you start bringing geospatial data to it, you'll be able to answer the question of where. And then you have your data science background and geospatial answer the questions of where and why things happens. So, and normally in data science, you forecast and you make predictions with the help of machine learning and AI. So you can also be able to, you can still do the same thing with geospatial data science, but this time you are making predictions for where, like where will flooding happen next year, for example. So for example, we had predicted that there will be flooding in Lokoja this year. Maybe we did that last year. We would have been able to prepare ourselves and plan mitigation measures. But because we have limited geospatial data scientists in Nigeria, we still have a lot of problems that we can easily avert with predictions. So as a geospatial data scientist, you can predict and forecast and answer different environmental questions. Where will this happen next year? Where will this happen next year? And even business questions. Where will this in space and time? So you have a superpower, you can be able to combine your knowledge of data science with geospatial data sets. You'll not be able to answer the questions of why alone. You'll also be able to answer the questions of where. And where matters a lot. So let's look at employability potential in GIS. Before we go into different opportunities, I would like to give us like a background of the geospatial industry. So the geospatial industry is rapidly growing. It's growing at a global CAGR of 12%, according to Fortune Business Insights. So that means last year it was $63.61 billion, and it's projected to grow to $147.58 billion in 2028. That's a lot. So it's, and you know, as we already established, geospatial data is everywhere. So that means if you can be able to use your knowledge of data science, or knowledge, or your any domain knowledge that you have, and you start looking at the geospatial data around you, and you can look at a problem to solve, you have a chance of getting a large chunk of this, billions of dollars of the global market. So it's a very prosperous industry that is rapidly growing, and if you can be able to find a problem to solve in this industry, you have a lot of money to make on the long run. And you know, technology is advancing. You have AI, you have metaverse, you have Web3, everything is coming. And at the end of the day, you can always combine this, technology advancement and be able to apply it in the geospatial industry and solve problems. So this is the geospatial industry at a glance, and 2028 is still far. Still have about 6 years to 2028. So if you have some ideas in mind, you have problems you want to solve, I really recommend you look into this industry and find a way to solve these problems, and you have a lot of money to make in the industry. Show the fact that it's still rapidly or slowly growing in Nigeria. So the rapidly is not, I'm not sure it's capturing Nigeria, because we still have limited use cases of geospatial in Nigeria. I mean, people use geospatial in Nigeria, but they don't know they are using geospatial, just like Jumia, as I've showed you earlier. Or those that even use geospatial in Nigeria, like Bolt is not a Nigeria-based company. Google Maps is not a Nigerian-based company. So, but Nigerian indigenous-based organizations are very limited. It's mostly government organizations that use geospatial technology. So if you can look at the problem in the Nigeria ecosystem, I'm very sure you can use geospatial data to solve it, geospatial technology. Just think of it. And if you can be able to do that, there's a lot of money to make in the industry. So that's for those that have startup mindsets, actually. But if you don't have a startup mindset, okay, if you still have startup mindset, those are just like the industries you can apply geospatial. If you can even suggest an industry that is not even listed here, I can tell you right away how to apply geospatial in that industry. Like, just think of the industry, you can apply geospatial in it. Military, climate change, agriculture, logistics, energy, oil and gas, telecommunication. No industry, because everything has geospatial data. So all this oil and gas, they have oil wells, and the oil wells are in a particular location on the Earth's surface. Energy, they have renewable energy plants, transmission lines, and these utilities are in a particular place on the Earth's surface. Logistics, they have checkpoints, they have control points, they have users that they want to deliver to, and these are just special data sets. Agriculture, they have farmlands. The farmlands are not in space, they are here on the Earth's surface. And when you can pinpoint something to a location with latitude and longitude, you can apply geospatial technology to that. Military, we have Boko Haram, they are in a particular place on the Earth's surface, right? And when you can know the way of your enemy, you can target and plan how to attack them, right? So climate change as well is happening somewhere. Oceans, sea level rise, everything. Telecommunication, we have masts. And even masts, not even just to monitor the location of your masts. If you want to install your mast, there are a lot of analysis that you need to perform, which all still require geospatial data sets. And I'm even aware that LCC, Nigeria Communication Commission, they have geospatial departments as well, that they help them to monitor their masts and operations. So just name the industry, you can apply geospatial data and technology to it. If you look at it deeply. So if you still have startup mindset, you can definitely explore this. But if you don't as well, you can also explore different jobs. There are different jobs out there for geospatial technicians. This is just a search on Indeed. So even if you're looking for scholarships to study abroad, there are different graduate scholarships. Erasmus, Chiplin, a lot of them. They sponsor people to study geospatial technologies in different universities across the world, as well as conferences as well. A lot of conference opportunities. So participate in geospatial conferences. And of course, there are jobs. I think even as at a few days ago, of course, the job market in Nigeria is very, very poor. So I need to mention that. You might not really see geospatial jobs in Nigeria flying around like that, but there are a lot of them abroad. But that's why we need to innovate in this space in Nigeria and be job creators and use geospatial data technology to solve problems. So after you are diving into geospatial, after you're trying to know what's happening in geospatial industry, after you're trying to explore geospatial, even after you've explored it, maybe via this training or any other trainings, it's still important to learn the fundamentals of GIS. You know, what I just gave you was like a brief introduction to GIS. GIS is more than that. Raster data and vector data are very, they are deep than that. The explanation I gave was just superficial actually. So they are more than that. So it's still important to explore the fundamentals of GIS. And because when you know the fundamentals of GIS, it's easy for you to think of application. That's why I said, if you tell me any industry in this world, I'll tell you how you can apply GIS to it. And that's because I understand the fundamentals of GIS, fundamentals of location. So I can easily think and come up with ideas of how GIS can be applied to that particular industry. But for you, you have a domain industry, for example, or data analytics background. So what you just need to do is understand the fundamentals of GIS and then start looking at how you can apply it in your domain of interest. And that's what you need. And if you have a data analytics background, it's like a smooth entry for you, because at the end of the day, we are still analyzing data, just that the data now has a location component. So if you're already familiar with Pandas library, we have the Geospatial alternative, which is the GeoPandas, which you can also use to do the same thing. You know, in Pandas, we have data frames. In GeoPandas, we have geodata frame. So you can interchange between the two. And if you have a data analysis background as well, you have worked with images before, say with NumPy, it's still the same thing, just that this time is not imagery. That's satellite imageries. So and at the end of the day, you still convert those satellite imageries to NumPy arrays. So like they are still the same thing. So you're not really doing serious switch. You're still able to use the tools you're familiar with, Python. And if you want to go the software route, you learn ArcMap and then you learn other softwares. So I want you to think of geospatial and come into it from application background or application point of view, and not you trying to go into geospatial fully and then learn everything about geospatial. It's more beneficial when you are learning it to apply it to a particular problem you want to solve, because it's very, very wide. Like it's very, very wide. Like I mentioned, you can apply geospatial in different industries. So you don't learn how to apply geospatial in different industry, trust me. But once you can understand the fundamentals of GIS, you understand the data structures, data formats, it's easy for you to apply it in different industry. And then you can also look at your current industry or the industry you have interest in. You have interest in agriculture, for example. Then you start exploring how you can apply geospatial in that particular industry. So that way to be beneficial for you. And you also need to, it's a rapidly growing industry, so you need to be in the know. You need to know what's happening. You need to join communities. If you're really interested in going deeper into the industry, you need to join communities. It's very important. For the women on this call, you can join the UIGIS. So UIGIS is African Women in GIS. If you love open source, you can join OSM communities. So OSM is acronym for OpenStreetMap, and this OpenStreetMap is powering a lot of the web maps that we see around us, like Bolt, like the geocoding system that Bolt is using, for example, is powered by this guy. The same thing with Apple. And Apple, I don't use iPhone, but those that use iPhone, your map is powered by OSM. But of course, Apple has changed the styling and kind of beautified it. And at some point as well, Google, of course, uses OSM. Amazon uses OSM. So this guy is very powerful right here. So if you're into open source, you can contribute to this guy, and Facebook also uses this guy at Meta. And then if you're still in university, you can also explore Gis Mappers community. It's a network for those in the university. A student-led network. So they also do GIS projects together. So it's very important to join a community for you to grow. And if you're active on social media, especially Twitter, you can follow this guy right here. What I built in 2020. So this guy right here retweets this hashtag. So if you check this guy timeline, you're going to see a lot of interesting stuff. This is an example. Now there's a see now Zipline is hiring a flight operator in Bayelsa. This is a GIS job opportunity. So this guy retweets this hashtag, GIS chats hashtag. So if you check this guy's timeline, you see a lot of GIS stuff that is happening all over the world, not Nigeria alone, it's global. So this is a job in Bayelsa State. So if you have experience with drone, you can check this boss timeline to apply for this job. And attend conferences and events. Africa GIS is like I think yearly conference or I don't know, I'm not so sure. People. And then there's GIS Experts that is happening next month as well, virtually as well. It's a conference to promote GIS in Africa. There's Geofencing that is happening next month as well. Geofencing Society of Nigeria. I think it's happening in Calabar. There's AGDIC, etc. So there are different conferences. So it's important you attend these conferences to keep up with podcasts. There's Africa GeoConvo, there's Geospatial, there's Mapscaping. Like there are a lot of podcasts, and these are like things that you need to do if you want to be in the know, because this industry is rapidly growing. There are a lot of tools that are being released every day. So if you want to be in the know and be competitive, you need to know what's happening, so that during job interviews, when they ask you about simple questions like have you attended Geocaching or stuff like that, you won't you'll be able to answer them easily. Or even aside interviews, it can also spice up your CV when you have conference attendance, and not just attendance. You can also give talks and speak at these conferences and present at these conferences. So this is where you get to this. That are not in the industry, you get to enter and penetrate into the industry like that, because you get to meet people at these conferences and then network, and that way you get to know people in the industry and until you become a part of it fully. And then you can also consider buying books. I do this a lot because I just prefer to have a resource to check when I want to disconnect myself from the internet. So you might not like reading books, or if you love reading books, you can download different Geospatial books online, and you can also purchase some online as well. It's very important. It's also a good way of being in the know. So this is a resource I have here for those that want to. I'm assuming we all have data analytics background. So this resource here is like going to tell you everything you need to know to be a Geospatial expert. So this is from Kato. So it's free, just register for it and then they send it to your email and then you download it and you can read it. And then this is GeoPandas. If you already know how to use pandas, you can check geopandas.org to see how you can use, add the geo to the existing knowledge you have about pandas. Yeah. Okay, thank you so much for listening. I hope.
Thank you so much, Mr. Emmanuel. We really appreciate your time. So right now, if you have any question for our facilitator, you can put it on the chat box or raise your hand. So I will ask you to unmute and ask your question. Okay, Rakib, can we have you? Rakib, you can unmute and ask your question.
Okay, can you hear me?
Yes, we can hear you.
Okay, good afternoon, everyone. My name is Rakib Akonwi. I'm a foreign level geology student of the Federal University of Technology, Mina. So I'm very glad to be in the midst of this kind of caliber of people, and my sincere appreciation to Mr. Emmanuel. So I just have a brief question, which is kind of giving me some headache. Is there any kind of difference between longitude and latitude and northern and eastern? Is there any difference between or similarity between the two? And I also want to ask if you're on LinkedIn, so that I can follow you on LinkedIn app. Thank you.
Okay, thank you for the question, Mr. Rakib. Let me try and share my screen to explain that briefly. Can you see my new screen?
Yes, sir.
Screen, and let's see if I can draw this real quick. So let's assume this is the globe. Right here. We have the east here. We have the west here. We have the north here, and then we have the south here. So longitude, let's say long, is also known as X, and lat is also known as Y, right? So when you say long X, it's usually to the east. You know, this is how it goes. It's usually going like this, longitude. So you can call longitude eastern. So these are lines of longitude. So don't look at the fact that they are coming from the north to the south. Look at the direction. They are either going to the east or to the west, right? It can also go like this, in this west direction. So it's still lines of longitude, just that it's going to the west and it's also going to the east. So that's eastern or western. Then for northern and southern is lines of latitude. These ones right here that go from the west like this, or like this. So this should be actually like this. Northern should be this direction. They're going up there. Why this one is coming like this, coming down south. Of course, from the way I'm drawing it, you can see I'm drawing it from west to the east. But if you check the direction the line is facing, it's facing down or either facing up. So, well, they are just basically the same thing. Longitude is X, and it can also be eastern or western. While latitude is Y, because it's on the Y axis, actually. All these movements is happening on the Y axis. That's why latitude is Y. But the direction is still either going to the north or to the south. So that was, I don't know if that helps to clarify.
Okay, thank you so much. Yes, but with this explanation, does it have any kind of correlation with grid?
What do you mean grid? Do you mean
Grid,
like
this kind of like box, like.
okay, well, so in the GIS world, there are different types of grids. There are grids that you can create yourself, and then there are global grids. And even the global grids have gone, they still vary depending on the use case. And this can also take us to projection. So, but what's still common between this everything is that longitude, you have a coordinates, usually X and Y. And this X and Y, if you plot it, will fall on a particular location on the Earth surface. So regardless of your projection, if you have this X and Y, or that's on a, I don't know if you want us to go into this because I'm assuming we have a lot of new GIS people here. So if you have a coordinates in this reference system, WGS84, which is representing the world like a globe, like this is how the world is. Let's assume the world is a geoid, as the scientists have mentioned. So the world is like this, the globe is like this. If you want to represent anywhere on the Earth's surface like this, you use this projection system, WGS84, that's X and Y. But if you want to represent the world, just like the way Google Maps represents it, flat, where you can see the line that connects your origin to your destination, we have to start looking at projected coordinate system. So on that projected coordinate system, that's where they represent X and Y using this, what you mentioned earlier, northings and easterns, measuring it in meters. So here, X and Y, long highlights are degrees, as you all know. You see it north, 8 degrees north, 15 minutes, then 33 seconds. Then you see east, 6 degrees. You know, that normal way we represent longitude and latitude in geography. So this way we represent it normally using this globe projection system. But when you start looking at using this flat projection system, it represents coordinates in meters. And that's where we use northern and eastern. So this can be divided into different grids. So grids, just think of grids as the way we have different time zones. We also have different grids. And those grids are like the, say, error margin, or how accurate these coordinates reference system are. So back then in the days, we have these guys called European Petroleum Survey Group, surveyors, EPSG. So they are the one that surveyed the whole world and divided the whole world into different groups, into different projections, into different coordinate reference system, such that there are different error margins across the globe. So if I want to measure distance, say distance from point A to point B, just like on Google Maps, when Google Maps says you're going to use 15 minutes to get to your origin and destination. So what Google Maps is using is a projection that is specific to Nigeria, for example. So in Nigeria, we fall in between 3 zones. We have zone 31, zone 32, and zone 33 of the UTM projection. So that projection, if you do any measurements, distance between A and B, in that projection, you're going to get high accuracy compared to when you use this global projection, this globe that measures coordinates in degrees, right? And even compared to when you use different projections. So these projections are different grids that represent different projections for different places on the Earth surface, basically, for different continents, for different worlds. So I don't know, maybe we can connect later to discuss this because there are a lot of details that go into projection. Projection determines the way the world is represented. When you use the different projection, you can see the world as love. There's a projection that represents the world like this, as love. There's some that represent the world as flat like this, some represent the world as globe, some represent the world as, so depending on your use case, that's what will determine the projection you're going to use. If you don't want to measure anything, you just want to pinpoint something on the Earth surface, you can just use the WGS84. In fact, it's the one that is mostly used, this projection system, World Global Geodetic of 1984. it's mostly used. It's also the same thing as EPSG 4326 for those that use EPSG. So so this into projection, and there's a lot of details, and these are things that I will encourage us to learn if you want to really understand GIS, because sometimes you can get data from surveyors that is in different coordinate reference system, and you want to work with that data set. So one of the things that you do first is to project it into reference system that is very good, or that is peculiar to the area of interest before you now proceed with your analysis. And if you use the wrong coordinate system, it's going to affect your measurement. You'll be able to get the result that you want. Say you are measuring the extent of your land on this type of projection, you can be seeing your land as 2 acres. Whereas when you measure the extent of your land on this kind of projection, you can see that the actual extent of your land is 4 acres. You can see the difference. And when you use a wrong projection, it can lead to poor decision making. So this projection also determines a lot of things when it comes to analysis and GIS. So this is what I would recommend us to learn actually as well. Thank you for asking that question, Mr. Rocky. I hope this rough sketch will be able to answer the question.
Yes, sir, it's very helpful. Thank you for the enlightenment, sir.
Awesome. Thank you.
Thank you, Mr. Emmanuel, for answering that question. Rocky, just try to be present tomorrow. The facilitator for tomorrow will be doing justice to coordinate system. So where you will learn about the 2 coordinate system, the CGS and the projected coordinate system. So basically, they are just like a projected coordinate system just tells your data where to plot on the flat surface. But tomorrow we'll have the facilitator doing justice to that, because it's a very crucial part of this GIS of a thing if you really want to dive into it. So I would like to call on Toib now to ask his question. Toib, you can unmute.
Okay. Hello. Good morning. I want to thank the facilitator for that very amazing session. My question is that there are some people that always say the GIS is somewhat related to data visualization. And can you please tell us more? Because as a newbie, maybe I'm more scared of charts and something, but can you please enlighten us more on this?
Yeah, thank you for the question. So let me use a quote to explain the answer to your question. So, there's this popular quote that says a picture tells 1,000 words, but when it comes to GIS, a simple map tells 10,000 pictures. So that's why you think people say GIS is more about data visualization. Data visualization is just one of the ways we report a GIS project. When you work on a GIS project, there are different ways to report it. One can be in just actually writing normal reports in Word documents. Some can be in preparing maps to visualize your outputs or results. And some can be in charts, even normal chart that you are familiar with, the bar charts, line chart and stuff. So there are different ways we visualize data sets. But one of the ways that is peculiar to GIS is the maps, because with maps you can tell, like I said, 1,000 pictures. Like with just a single map, you can answer and infer a lot of information, a lot that you might need hundreds of paragraphs to even communicate. So GIS is not entirely data visualization. For myself, that I'm into geospatial software development. It's rare. It's been long I created maps. I mostly do web maps. And I don't really visualize. Of course, I visualize at the end of the day, but there are different aspects to GIS. It just depends on your application actually, and some can require you to create maps, which is not like entirely difficult per se. It's not like super difficult. In fact, it's much easier than creating thousands of charts just to communicate the results. With maps, you can just plot X and Y, and then you see what's happening somewhere. So don't be afraid. It's something that you actually enjoy. Trust me, something you actually enjoy. So GIS is not just about data visualization. It's just one of the ways we present GIS results or GIS reports. There's more to GIS. I hope that answers your question.
Thank you, Mr. Emmanuel.
Yes, thank you very much, sir.
Okay. Thank you, Mr. Emmanuel. Yeah, like what he has said, that GIS as a data visualization tool, we have what we call Gis Dashboard. So as we proceed, you get to know more about this. It's not just data visualization. In GIS, we visualize real-time data, like your data when you create your dashboard. With time, probably you receive a response on a survey and all, then your dashboard will keep updating without having to do any input whatsoever. So I think you're trying to show us dashboard, right?
Yeah.
Okay, good.
Can you see my screen?
Yes, we can.
Can you see this on the map?
Yes, we can.
Okay, cool. I'm just trying to show an example of a dashboard that is developed by World Food Program to show the global hunger map. So this is just one of the outputs of GIS. But what is actually like the main work that is powering this platform is a lot of analysis process, right? That is presenting this result like this. So before you even start thinking of presenting your results, you would have performed a lot of analysis. And that's the fun part. So this platform is just showing us the hunger maps of different countries. So when you zoom to a particular country, you see on the sidebar the food security level, the nutrition level, and then chart. You can see this is a chart now. You can see communicating results, right? And here's a different ways we represent the gens. And then when you over on a particular maybe county, you see the charts and also the information about that place. So this is a GIS right here, but it doesn't mean that, of course, visualization is very important because you need to know how to communicate your results, but there's more to GIS than visualizing. What's happening are different statistical processes, calculating this percentage, these charts and stuff. So these are the fun parts. This was just like the icing on the cake, actually. It's not really the sweetest part. The sweetest part is putting all this together and making it interactive. And this is still one part of GIS. Yours can be maps and not necessarily even dashboard. It can just be maps, just normal maps. So yeah.
Okay, thank you. Yeah, there are some questions on the chat, so I will read them out now for you to help us to do justice to them. Okay, someone asked on the chat box that can they have the slides that you use for the presentation?
Absolutely.
Okay, I'll get the slides and put it on the WhatsApp group for everyone to have access to it. Okay, regarding the recording of this workshop, I will talk to Mr. Ahmed and see how we can get it across as well. Okay, we've answered that. Okay, another question. My question is, how do you get to determine which data is represented as vectors or those that will be in rasters?
So that's a very good question. So it depends on you, actually. If, as you can see now, let's even use this dashboard to explain answer that question. So on this dashboard now, all we have here are vector data sets. These boundaries are vector information. these boundaries, you can see they are polygons. So these are vector. If I go back to global, you see now they are now points. These are points, which is still vector, right? So if you want to, I can't use raster to represent it because raster are pure images. With raster, you can't really derive, like it's not really, it doesn't really fit. This use case is to show you hunger in a particular country. So you can't really use raster data set, which is more or less satellite imagery, to show us the hunger level in a particular country, right? Because on satellite imagery, what we're going to be seeing will be buildings, just buildings and everything that the satellite can capture. So you do that to a decision maker, or even to your, if you look at that yourself, you won't really know those that are actually experiencing the hunger. But with vector, when you zoom into a vector data set, you get to see the boundary of the states of interest. Because with raster, you won't see boundary. The satellite is just capturing everywhere on the Earth surface. On the Earth surface, it doesn't know that this is the boundary of Oyo, this is the boundary of Ocean, this is where Ogun stopped, this is where Lagos started. It's going to capture everything together. But it is us that will not, that we have boundary, administrative boundary, and borders and stuff like that. So with vector, you can be able to represent those features. That okay, this is the border of Ukraine. You can even color it that okay, this place they don't have hunger, this place they have hunger, but this place we're going to collect the information about them. You can see the prevalence of insufficient food consumption. So you can do all this kind of styling to vector data sets. You can't really manipulate raster data sets this way. Another thing is that raster are very large. Satellite imagery can go into terabytes of gigs. Just the satellite imagery of maybe a particular country, it can be that large. So you don't want to put terabytes of gigs on the web platform. It will be super, super slow. So that's why we use vector to represent and present information to the users. Understand? That's why you can see people cannot use raster or satellite imagery to show you the routes to your house, to show the lines, because that way it's faster to analyze. It won't really waste consume much bandwidth, because vector and raster consume bandwidth because they're very large. And if you're trying to download large data, it will consume a lot of bandwidth. But vectors are very light, and now with the advent of vector ties, so let me zoom out. If I zoom out, you notice that there's some white background before the images load. So those are like vector tiles. So this, the old word, in fact, this is even the perfect example of projection. So this is a projected coordinate reference system representing the whole world on a flat surface. Ideally, as we are taught, the word is a geoid, so we should be saying something like globe. But now we are seeing a flat surface because it's having it on a flat surface will make it easy for us to analyze. We can easily measure distance between this place and this place compared to when it is globe. So now, if I over on these countries, you can see it's very faint though, or it's showing the borders or the boundary of those countries. So those are vector data sets. Those are vector data sets. Then all these points as well are vector data sets. So with vector data sets, you can be able to do all this kind of visualization. We can manipulate. Of course, raster data set visualization as well, or we can't really do much compared to. So that's why it depends on what you want to communicate. If you want to communicate different information, if you want to communicate, say, land use, land cover, of course, you have to use raster information. So this is for Nigeria. So there's a very high insufficient food consumption towards the north. And then we have very low or low insufficient food consumption towards the south and FCT. So you can see these are boundaries. On raster imagery, you can't see boundaries like this. You don't even know where they you don't have like a raster base map. I'd love to show you. Let me just show us raster, how raster looks like. So on raster, what you see is pure imagery. These are vectors. Yeah, these are different points. People just yeah. at the end of the day. Okay, let me see that's imagery based map. Reading. Yeah, satellite view. So this is a raster. So from this raster now, of course, Google is still about the vector on it because there are still lines and points on it. But ideally, when you have raster imagery, this is what you have without all these lines from Google. So from that, let me go zoom out. From this information, you can't really derive any from it. The only insight you can do from it, analysis that has to do with you measuring, say, for example, in vegetation, you want to measure the vegetation health. And you know, this satellite imagery captures the Earth in different electromagnetic radiations on different bands. And different bands, with different bands, you can be able to analyze different, can be able to perform different analysis and get different insights. So that kind of analysis you can use raster data sets. But for the ones that you just want to visualize and present something, it's best you use vector information. So with this now, you can see this is a word, you can see this is how the word, or this is how they tell us that the word is. So right here you can just visualize just for visualization's sake. But when you want to start measuring, the word will be projected into flat surface, and then you can perform measurements. You measure from this globe point of view, getting a very poor measurement. So yeah, there are a lot of interesting stuff actually. A lot of interesting stuff that is into GIS, that is in GIS. A lot of very interesting stuff. So I think the bottom line is your analysis will determine the kind of data set you're going to use. You can combine this together, it's fine. And you can decide to go with just one. You can also decide to go with the other. If, for example, you've performed that analysis and you have raster data that's very, very, very light, like just 1 MB, you can also present this now. Why not? So present it. When you're looking at a country-wide analysis, it might be advisable to use raster datasets to visualize raster information, unless you've tiled it. It's not into tiles, or unless it's very light. So your analysis will determine the kind of data format you're going to be using to present your project. So this is raster data set. This is how the satellite captures the world. So what we just do is to carve out these buildings and convert them to polygons. These roads, we convert them to lines. So that way we can be able to do more with them. Okay, so I don't know if that answered the question.
Okay, Mr. Emmanuel, thank you. To add to what Mr. Emmanuel said, raster basically is just for you to derive a kind of workable format that you can, where you can perform your analysis. If you really want to perform your analysis, maybe you're using ArcMap, ArcGIS Pro, or WebGIS, you have to have this SHP format, shapefile, where you store your feature classes, the polygon, lines, and points, to do further analysis and to be able to visualize your results and all. So we'll proceed with the questions. I think we have other questions here. Okay, regarding the software installation, you can only have access to the software installation directly from UIGIS. If you are a UI student, or you are a UI staff, or presently you're working on a research that is GIS related. And if you're on the WhatsApp, and if you're on the WhatsApp group, I think some people have posted links where you can get a software you can start working with. So I think I've answered that question. Okay. I have another question for Mr. Emmanuel. How do you apply GIS with Web3 spaces? What is the connection?
That's a good question. So there are different applications of GIS and Web3. There's even one I've seen recently, which is very interesting, which is you having a digital version of land, having your own land, like buying land in a digital land, sort of. Let me click on buy land. So then also drop this on the chat as well, in case you want to check it out. It's a very cool feature because I've also been researching that line and I saw it and it's very interesting. So I thought I should share it. So over here, you can buy land from anywhere on the Earth surface. Digital land though. So the concept is very funny. You can also read the concept when you get to the website. So people are buying lands from different places. So you can see this is still GIS. These are maps. These are raster data sets loading actually. Satellite imageries loading in types. So you can zoom into anywhere on the Earth surface and then you buy any land you want to buy. We have blockchain, of course. Then even aside that, Web3 blockchain is more like a distributed, more like a decentralized system. So whatever application of GIS you can apply in the current centralized system, there should also be the possibility of you doing it in the decentralized system, right? So, it's not limited to this kind of platforms at all. You can also do more and think of better ways to even apply GIS than applying virtual lands. But this is just very interesting platform, so I thought I should share it. So they buy different tiles. So yeah, the price is coming up. So yeah, we have different tiles like this. So and they have different price tag. So you click on the one you want to buy, you see the price, and then you purchase it. So now this land is now for you virtually in the Web3 space, which is very interesting. So like different interesting applications of GIS and the company that they use, like the GIS company that they use their products, or like that they use for this platform is Mapbox. So that's right here. So if I click on Mapbox, you see that Mapbox is powering a lot of companies, a lot of industries. For example, in mobile cars, in mobile cars you have navigation, like Tesla, for example, you have navigation and everything. So Mapbox is the one that powers most of these companies, mobile cars, navigation, self-driving cars, and everything, self-driving vehicles. So you can see, yeah, Toyota, yeah, the one that's currently doing it for Toyota. Now, if you know Strava, if you're the one, you're like into Strava, this app that they use for exercise. Strava also uses Mapbox technology for their base map. BMW as well uses Mapbox for their maps. So Mapbox uses is that they're very, very skilled, like they're very, very powerful when it comes to building navigation system. They're like the contender for Google actually. They're like the alternative to Google, like competitor to Google, this guy right here. So yeah, so there are different applications of GIS, a lot of them. Like there's this quote by Jack Dangamon, the founder of GIS. It says that the application of GIS is limited by the imagination of those who use it. That's us, with the users of GIS. So the more deeper we can innovate or think of how to apply GIS, the more we get to see that GIS is powerful. So if we don't know how to use GIS for land use, land cover, or for studying, for simple stuff, that's the only thing we're able to use GIS for. But if you can innovate and think of, more powerful ways and more, innovative ways to use GIS, you'll be surprised that GIS can be used and it's even more capable for that kind of use case. So GIS is just very, very interesting. Very, very interesting. I actually tried this globe map view as well. It's very, very pretty cool stuff. So I love to explore. I love to explore a lot. So exploring Mapbox products. and I tried their globe view just to see how it looks like. So let me just show you the map view. Right down it comes up. Something like this. Something like this. So I tried it out to see how it looks like, and it actually works. So these tools are there for us to use. We just need
please, what do you call do?
to innovate and build stuff. So these are like people that are posting projects on Spatial Node and can get to see the projects information for the country. Right. So all these tools are there for us to build for us to innovate. We just need to. So this one works on deforestation in Brazil. So we just need to think outside the box and build powerful solutions. So yeah, the tools are there. We don't have issues with tools when it comes to GIS. There are a lot of tools out of the box. So Web 3.0 is just, it's like even to be the minor thing for us to apply GIS to, because we've applied GIS in more advanced industry. So if you have an Object 3.0 background, what you just need is to look at the problem to solve. Don't worry about how GIS can be used. Just look at the problem first and then research in that line. You'll be surprised that you can use GIS to propose a solution in that space. Okay, so this is this thing from National Space Station from Google Maps. So yeah, any other question? I think our time is fast spent. I don't know.
Okay. Another question is, which network do you recommend for studying to understand the basics of GIS better?
So from that, so there's this book I recommend. GIS. So just search for fundamentals of GIS on Google. So there are different books actually, but there's one that
I can't hear you.
Oh, sorry. So I said there are different books where you can learn GIS. So just search for fundamentals of GIS on Google. You see different free books and different. Yeah, this is the one I recommend. This guy right here, by Paul Bostad, GIS fundamentals. So of course there's the free version online. You can search very well. But let me just drop the name on the chat. So if you can search very well, you can go with Googling, you'll get the free version of this book right here. This book is very, very good. It goes into details like fundamentals of GIS, points, lines, polygon, raster data, vector data, multi-polygon, like everything in detail. So yeah, that's the book I recommend.
Okay, we have a question to ask. We can unmute now and ask.
No, I don't have any question.
Okay. Okay, Mr. Emmanuel, someone asked earlier that can you give us your LinkedIn profile link so that it can connect with you?
All right, sure.
Okay, you're supposed to put it in the chat box. And please, when you are sending your connection, try to make it a personalized one, such that try to write in your message, I'm so we met at UIGIS workshop, so that it can accept your connection.
Okay, thank you so much.
Okay, you sent it? Okay. Yeah, Mr. Manuel, thank you so much for having you today. Even despite your busy schedule, you still honor us and be here and share from your knowledge. And so far, I believe everyone must have received value today from this presentation you did. So I would like everyone here, if you have received value today, let's just type value on the chat box to appreciate Mr. Emmanuel. Okay. Okay. Yes. Okay, that's good. So tomorrow we'll be having this workshop presentation again tomorrow by 10 a.m. I would like everyone to be here to come and meet Mr. Raymond, who is a GIS specialist with over 5 years working experience, mostly in the electricity distribution sector. So we'll be glad to have you again tomorrow. We appreciate everyone who is present on this workshop presentation and hope to see you again tomorrow. Goodbye, everyone.
Bye, everyone. Thank you for having me.